Sorry. Welcome everybody to Learn with Lowell. Today we're joined with Greg Skomal, a leading shark expert, specifically focusing on the great whites out in New England, author of Chasing Shadows, which is coming up July 11th, which I have been reading, and it's great. I recommend it. He's been featured in National Geographic, Discovery Channel, ESPN, numerous networks. You've probably seen Greg somewhere if you're interested in great whites at all. So, and remember to subscribe and all that time fun stuff. But Greg, welcome to the show.
Good to be here, Lowell. Thanks for having me.
We were talking about turning points off the air a minute ago, and you mentioned one that I definitely want to just dive in there and have fun with it. But you talked about a white shark being trapped in a salt lake for a couple of weeks as a turning point in your career. And so I just thought it would be fun, just start there and dig in.
Yeah, I'm happy to talk about it. That shark ultimately we named Gretel, and it was a 14-foot female white shark that zigged when it should have zagged and ended up in an estuarine environment, which is this tidal salt pond, where it became trapped for 2 weeks. Now, up until that point in my career, most, if not all, of the white sharks I had ever seen, which was just a handful, were dead animals caught by fishermen, brought to the docks. We would do dissections on those fish. We would learn about their biology by looking at their various tissues. But I had never really experienced a live white shark. And here I had one really in my backyard because I wasn't living very far away from where this event was going on. And the first thing I wanted to do was just not only admire this incredible beast that was there, delivered to me, but also to get a highly sophisticated tag into its back so we can track its movements, assuming it left the salt pond. To make a very long story short, it is absolutely a major part of the book, and it's a chapter in the book because it is a pivotal point. That shark chose not to leave immediately.
A quick note, Uncle Sam wants you to help make this show successful. Subscribe and become a member today.
And became what we thought was trapped, refusing to leave this salt pond, which was challenging environment for the shark. So it took us 2 weeks, 2 very long weeks, using all kinds of options available to us and some unavailable to us to try to motivate what we thought was a 2,000-pound white shark to leave this area. And ultimately, we succeeded. And I did tag the shark. We put a highly sophisticated electronic satellite tag in this animal. But here's the kicker. And well, I'm not going to tell you the kicker because it's in the book. But we did get the shark out. But the message it sent to me, I really think it was a message telling me that white sharks were starting to come back to New England in larger numbers. And it took a few more years, but ultimately I would go on to discover that white sharks were indeed returning to the coastline of Cape Cod. And ultimately we would go on to tag another 300 sharks. But the fun part of that is what we learned from its tag or what we didn't learn from its tag, which you can read in the book.
So what's your hypothesis for why I liked that saltwater pond? I mean, like, what was happy there?
It's a great question because we don't know. We couldn't get in the head of this animal, and it certainly wasn't talking, unfortunately. My guess is because this was a tidal estuary, and all that means is water flows in and out of these pond systems like it would a bay, like Delaware Bay, Chesapeake Bay. Water's flowing in and out, but a much smaller embayment, and the shark on high tide must have been in hot pursuit of either something to eat or got into the shallows and struggled a bit and then moved in the wrong direction. Remember, we have the advantage because we live on land of seeing where to go if we go swimming. Where do we want to swim? If we're in a pond or an estuary, we know where we want to go. Shark is underwater. So the shark is trying to escape these shallows. And I'm guessing that it swam to this deeper part of the pond where it was comfortable, but when the tide went out, we realized that it was in essence trapped.
Oh. When So there's a ratio for how big an animal is and how big their brain is. And I always think of, whales, how big, especially the blue whale, how big it is and how big its brain is, and how we think they have languages and all these other things going on. For sharks, in a couple of your talks and even in the book, you make this joke like they're dumb, they're getting mistaken like seals for people, and that's why they nibble at us. But when you look at a 2,000-pound shark, how intelligent is it? How big is their brain? Do you look at that element of sharks when you're researching them as well?
Well, if you look at the brain to body mass ratio, which is a typical scientific index that is thought to give scientists a sense of the intelligence or of an animal, and we've done this with everything from humans to other mammals to birds, fish, reptiles, amphibians. Sharks are actually have a higher brain to body mass ratio than many other species of fish. And all this means is that relative to their body size, they have a pretty good sized brain. But but all the best available science, when we really drill deeper into what that means in the case of sharks, we find out that most of the brain of the shark is dedicated to sensory biology, sensory systems, whether it be eyesight, electroreception, sound reception, you name it. So the brain of the white shark is dedicated to trying to find prey. Now, I don't like to use the word dumb because they're really not. They're instinctual animals. They do learn. They're capable of learning. All sharks, that's been demonstrated in. But I don't think they're NASA scientists. They're not doing complex math in these brains. They're really simple, relatively simple animals that are born, they live, they use their brains to locate prey, to survive, to locate mates, to reproduce, to perpetuate the species. When it comes to intelligence, it's really hard to measure that in fish, if you think about it. It's much easier in higher vertebrates. So in fish, what you try to do is training exercises and those kinds of things. And that really hasn't been done with white sharks. But we do know they do learn because many white sharks will habituate to situations where they're being fed. And what I'm talking about is generally white shark ecotourism opportunities around the world. So there are places you can go where white sharks will show up to boats that will feed them or at least draw their attention with food. So that people can go in the water and photograph them. And it's really fun, exciting opportunities. But obviously the sharks are becoming conditioned and habituated and are able to learn that that's a source of free food. So to that extent, in many ways they're intelligent, but it doesn't go much beyond that.
Yeah. Well, what would your guess be for a terrestrial animal that people are familiar with, like a cat, dog, or whatever, in terms of how it compares to a shark intelligence? It sounds like it's dumber than a dog. Like dogs are pretty intelligent, cats are pretty intelligent. So it sounds like it'd be below them. Just like for frame reference for people who don't see a shark on their daily basis, like what would it be like to just like stroll around? Like what is the intelligence looking back at them?
Yeah, I would put them below most mammals in terms of intelligence. Absolutely. But when it comes to fish in general, they're probably at the upper end of the spectrum because they can to some extent learn. What I find remarkable about many species of sharks, including the white shark, is you'll have a white shark that comes to Cape Cod to feed on seals, and then it'll travel literally hundreds to thousands of miles away during the off months. So during the winter months, it moves back south, but then it can come straight back to Cape Cod, each year. So the ability to navigate and find locations, learn those locations as being profitable places to eat, and then come back to them each year. It's like finding a restaurant they really like, but imagine swimming 1,000 miles away and swimming back to that same restaurant. So, I don't want to sell them short on their sensory capabilities, navigational abilities, because I think they're really quite talented at that.
If you put a mirror in the water, do they recognize themselves? Like you put like with most animals, they put like a spot or something on their head or whatever, and they like, oh, that's me. Like I have the spot on my head, and they try to mess with it.
Good question. I don't think anyone's ever done that with a shark, a white shark. And I don't know what would happen. My guess is that self-recognition, I don't know. I'm stumped on that one, Lowell.
Hmm.
I don't know how a white shark would react to that.
And then, so they learn they can be habituated to different environments. Do you think there's any element of a shark doing like monkey see, monkey do, and following other sharks that already know the pattern, and then once they get locked into the pattern of going these 100 miles, there's like a loop of it? And this is assuming that all sharks do a similar cyclical pattern of migration. So how do you think there's any element of like them teaching each other where to eat, or is it just like they have really good senses and they just are all naturally finding them through the senses?
For the white shark, we think they're generally solitary individuals. And when they're not mating, they generally avoid other white sharks. And we certainly have seen instances, or at least evidence of instances, where white sharks, when they come in contact with each other, do not get along. There are bite marks that we've noticed in white sharks that are clearly from other white sharks. So there seem to be negative interactions between sharks that are likely linked to, competition. So it's, social interactions that are, for the most part, negative. So we've got no evidence that there's learning or teaching going on in any way. Now, there are species of sharks that will aggregate or school. They'll form shoals where they hang out together, and even feed cooperatively. That's been demonstrated in a couple of species, but not many. It's very, very rare. Most sharks are solitary individuals until they need to mate.
Yeah, they sound similar very much to polar bears, and that's why I was kind of wondering in that regard, because as the resources have been dwindling for the polar bear people, they have been starting to work together more and more. They used to be these solitary creatures, but now they're working together to eat sometimes. And so I was wondering if there's any of that going on, if there's any adaptation. Though sharks themselves are pretty old species. I think they're much older than the polar bears. But I always am very curious as the planet's changing, how are animals adapting to it?
No, it's certainly something we're looking at and we're watching. We haven't seen any evidence of that as of yet. A big white shark that is feeding or attempting to prey upon big prey like seals or sea lions is going to want that prey to itself. We have no evidence of cooperative feeding. And as I said, if anything, we've got more evidence of, the old get the hell away from me kind of attitude between these animals.
Yeah, and then for the traversing long distances, do we have a prevailing theory on how they do that? I think some birds, when they migrate, I think it's like something with magnets, like the magnetosphere, they're able to kind of figure it out from there. But there's also like dead reckoning with like ants and whatnot. That's research has been done. So what's like the prevailing theory and how they're able to find their way back and find food like that?
Well, I mentioned a little bit earlier that white sharks and all shark species have electrosensory perception.
Mm-hmm.
And that means is that they can detect electrical fields. Now, when they're preying upon other species, they use this as a near field sensation. So a white shark, for example, as it's closing in on its prey, and I say generally within a few feet of its prey, and these are ambush predators. So they strike with force and speed, and they want to ambush their prey. When they get very close, they also want to protect their eyes. So what they'll do is they'll roll their eyes back, and they'll rely on these electrosensory receptors in their face, all over their nose and around their head. And that detects electrical fields and allows the shark to really hone in on its prey without necessarily having to see it. Now, this electrosensory perception also allows the shark to perceive magnetic fields. So broader magnetic fields, which allows it to navigate. So it's been demonstrated in a couple of species, not the white shark, the other species that are related, that sharks can use magnetic fields to navigate over broad distances.
That's pretty wild. So it's like I forget the term for this, but it's when something's been evolved to multiple different species. There's like a term for, it's like crabs for some reason, like the structure of a crab like keeps being re-evolved in different places on the planet. So this ability to use magnetic fields seems to be something that just every animal are plugging into pretty effectively to move around and find prey or find home or find shelter and stuff like that, in terms of like geese and stuff. That's pretty cool.
Yeah, I mean it's worked for us as well.
Yeah. We can do that as humans. Humans can check
No,
that type of
no,
stuff?
we develop instruments that allow us
Ah,
to sense the Earth's magnetic field, and therefore a compass, for example, that allows us to go in the
okay.
direction that we want to go in. We don't have, to my knowledge, magnetic reception.
Yeah, it'd be cool if we did. The
Yeah.
uh, have you how well do we know the sphere of influence of a shark's sensors, especially when you tag them? Do you go like 2 miles in a direction, like drop blood in the water or something to see if they respond to it? And then like how big of a like I don't know, I think of it like sphere of influence does a shark have as it's moving through the water? And I imagine it like gets like stronger as it gets closer to the shark, as it, and then it like tips its eyes back and it's like really tight in terms of sensory.
Yeah, I mean, it really points to this complement, this array. Think of it as an
Mm,
array of
yeah.
sensors that these sharks use. Many species do, right? Including us, except we don't have as many as sharks do. So, clearly sound and smell are long distance receptors, and it's thought that those are effective over, hundreds of meters,
Wow.
perhaps not miles, but hundreds of meters, where a shark might pick up a scent trail, or maybe perceive a sound, a low frequency sound generated from a great distance. And what it tries to do is localize those. Uh, what it does, let me start that over. What it tries to do is find the source
Mm,
of those sounds or smells. And once it starts moving in that direction, it picks up on the trail. It's able to go toward the source because it orients in that way, and that's the way its receptors work. It can figure out the directionality. And as it gets closer, it eventually will shift toward eyesight.
mm,
Eyesight's a near field receptor, but it depends on water clarity, right? If you're hunting off a murky beach near Cape Cod for gray seals, for example, you're going to have to really be close to see your prey. But if you're down in off the coast of the Florida Keys, you probably will be able to perceive your prey from a much greater distance. So distance will be tightly linked to water clarity, visibility, sunlight, those kinds of things. And then as you close in, within meters of your prey, you're going to switch to perhaps perceiving what the prey is doing in terms of pressure. And that's where you use what's called your lateral line system. And those are pressure receptors that allow the shark to basically feel its environment and feel disruptions in its environment that would be indicative of a prey item very close. So now you're relying on your lateral line receptors and your eyes. And as you
mm-hmm.
really close in, you see your prey, you accelerate with speed, up to speed. And then, as I said earlier, you'll roll your eyes back to protect them. You'll open your mouth, and you rely on your electro-sensory perception to really allow you to close in when you're within a couple of feet of your prey, so within a meter.
Mm-hmm.
And then once you bite your prey, you're going to determine through taste whether or not it is indeed a prey item or a
Mm-hmm.
mistake. Is it a piece of garbage? Is it something you don't normally eat? Is it a human that you've bitten by mistake? Because that is what happens. Rarely, but it happens. And then you release the prey, or you continue to consume it if it's, your gray seal that you're after. So that's how the array of senses works.
Mm-hmm.
And each one kicks in depending on your distance from your prey, and allows the shark to hone in on its location.
If Are we able, I don't know how you would test this, but are we able to determine how well they can see? Like how eagles can see like a mile away and like really clear clarity. Do we know how well a shark can see generally in water? Like it's like 2020, I don't know, like a frame of reference on this.
Well, we can certainly look at the morphology, or in other words, the structure of the eye.
Yeah.
Compare it to other vertebrates, right? How's the eye of the shark? We see that it's got rods and cones in the retina, which is very similar to most species, most vertebrate eyes. There's a lot of rods, a lot of cones, which means that the shark is good in sunlight, as we can see well in sunlight, as well as in low light level situations, right? In terms of actually testing how well in its visual acuity, there are a number of tests you can do, but usually it relies on an animal in captivity and training that animal, and then presenting, some sort of stimulus and seeing how it reacts relative to how it sees it, how it perceives it. And those kinds of studies have been done with a number of species of sharks that can be held in captivity. And those tend to be smaller, sedentary sharks and not the more dynamic, larger sharks as we see in the case of white sharks. We also look at, where the eyes are situated on the head. If you look at a white shark head on, it almost looks like a bird in the sense that the eyes are looking forward, which is very typical of top predators. Very good visual acuity, very good eyes for honing in and locating their prey and successfully, attacking and consuming their prey, like birds. But, the experiments are a little bit more difficult when you're dealing with marine animals.
Mm-hmm. So you tagged 300 plus sharks. And so you have the part, I think you called it the white shark shuffle, when they like try and jump up and try and eat you when you're on the little boom thingamabob. But in between the moment where you tag them and maybe they've decided not to eat you and they're just kind of swimming around looking at you, what does that feel like?
Well, I think you're referencing, so we go in the book about, talk quite a bit about our tagging technique, which is, fairly unique on a global, in the world, because we don't use chum or, which is an attractant. We don't ground up fish. We don't use any attractant to draw the sharks to us. We actually use a plane, and the plane is flying in the air, looking around for white sharks that are hunting the shallows of Cape Cod, Massachusetts. And once the plane locates a white shark, he then directs the captain of our boat, and the captain is in a tower, a high tower on the boat, to the location of that animal. And we'll zip over to where that shark is. And it's generally within a quarter mile of the beach, swimming in relatively shallow water, meaning, generally less than 20 feet deep. And the shark, if it's swimming near the surface, the first thing we'll do is try to get some videotape of that animal. And we go into detail about why we're doing that. We can differentiate between individual sharks looking at their individual color patterns. So we'll get video of that shark, and I'll do that from the pulpit of the boat, which is the stand, which is that kind of walkway, the plank that I walk out on, right? And once we get video, and if the shark isn't spooked by us or by the boat, and the reason I'm way out at the end of that walkway is because I'm trying to avoid the shark perceiving the bulk or the sound, the noise generated by the boat to scare it away. So I'm out ahead of the boat. Think of me being, suspended 10 feet ahead of a big noisy boat. And so if we successfully get videotape of that shark, I will then attempt to tag it, assuming it stays within the top, 3 or 4 feet meter of the surface. So that shark is swimming along, paying no attention to me, and I'm going to try to insert a tiny little dart at the base of its dorsal fin, which is the standard shark tagging technique that's been around since the early 1960s. And I'll use a very long tagging pole, and the tag itself will be either an acoustic tag, a satellite tag, a camera tag, one of the many kinds of tags we're using. If I can successfully place that tag, right, I'll do it. And the shark will typically flinch because in essence, I'm spooking it. People ask me all the time, does the shark feel any pain? By all accounts, based on all the published studies relative to pain in fish, there's no evidence that the shark experiences pain, but I am spooking it. Not many things sneak up on big white sharks and touch them. And that's what I'm doing. So the shark will spook and it'll flinch and it'll generally swim away, or it'll continue on its business. The episode that you referenced is one of those times I was out there about to get video of a white shark, and the water was really, really murky. It was like it was like coffee, to be quite honest. And I couldn't see the shark. So I'm looking down from the pulpit of the boat, from the stand, and I'm looking everywhere. I've got my camera on the end of a pole. It's a GoPro camera, and I'm waiting for the shark to appear so I can do a couple of sweeps of the camera, get some good video to identify it. Suddenly, out of nowhere, out of the depths, comes a white shark with its mouth wide open underneath me, and in an attempt to perhaps bite what it perceived at the surface. So for a split second, I was looking down into the open maw of a white shark with its jaws flared and its teeth extended. And I don't think that's a sight anybody wants to see. Now, fortunately, I'm 4 feet off the water. The shark didn't get to me. I'm protected by the stand itself. And I wasn't threatened, really. But it was an eye-opening moment. It's only happened once to me. It was a shark that clearly perceived me or the image of me at the surface as a potential prey item, perhaps confused by the dark water, the poor visibility, and made an attempt. We spooked it in some way, or it made a valid predatory attempt. But nonetheless, it was a little bit disturbing, and we captured it all on video. And needless to say, that video went viral.
Mm-hmm. Yeah, I watched that video. I would have immediately retreated, but you seemed like you stood there and just knew everything was fine. But that's the expert in you knowing all the details.
Well, you referenced the white shark shuffle. So
mm-hmm.
when that happened, if you look at the video, you see I kind of moved my feet going, oh my God, is this thing going to get to me? Mm-hmm. So we called that the white shark shuffle after that. And luckily, I haven't had to do it again.
Yeah. Or unlucky. Maybe that's a unique experience to learn something new.
I think only one of those is good enough for me.
So Cy Montgomery, which is how I learned about you, has been on the show and has another episode coming up. I don't know if it's up yet by the time this is up, but she talks about in her book, The Soul of the Octopus, how when you look at the octopus, it feels like something's looking back. And so I'm wondering at the personality of a shark, when it's not trying to eat you, when it's ascertained you're not food and you're just like tagging it and it's kind of going around you, is there something that looks back at you that like you feel anything about, like in the same, like I can just vividly think of how Cy Montgomery describes octopuses, but octopuses are like incredibly intelligent. So like it might be apples and oranges here.
Well, first I can't say enough about my friend Cy, a phenomenal writer, and she did a book about us called The Great White Shark Scientist a bunch of years ago, in the line of her octopus book. Same concept, and just I met her actually, I want to say over 30 years ago when she was writing a story about sharks for the Boston Sunday Globe magazine, which she published, and she hung out. We took her out shark fishing off the coast of Martha's Vineyard many years ago, and I love her dearly. But she talks about an octopus staring back at you, and initially I was thinking, well, white sharks don't do that. And I thought that years ago. But now, after spending so much time, and the book really highlights, all the experiences we've had with this species, and, from the breaching shark to the research we're doing. And the fact that we've named them, we've named a lot of these white sharks that we've tagged and identified off the coast of Cape Cod. I have seen them look at me. I've seen them look right up at me on the pulpit, and it can be a little bit unnerving because many of these fish are clearly, are in excess of 1,000 pounds. They're notorious predators. They're probably the most vilified species on Earth. But the more time I spend with them, the more I get to know them. And I know that sounds strange. The more I could see the subtle aspects of their behavior. A white shark could be swimming right underneath me, and then it might tilt its pectoral fin, which is like its arms, right, down and spin up, and I can see it, just look up at me. I could see its eyeball, I could see its eye move, and I know that thing is checking me out. It's wondering what I am. And sometimes they'll go deep and say, I don't want any part of that. And sometimes they'll just keep swimming along, almost like they know who I am and what I'm doing, which, I can't be sure of. But yeah, white sharks, they do. They perceive us. And I don't know how they perceive us, but they certainly do see us.
When it looks at you, I'm curious, does it give you a feeling that you would want to chase? Like in Cy's book, like that whole feeling kind of perpetuated the whole book in terms of her wanting to explore what that meant. But when you look at the shark, is it just this thing wants to eat me, or just trying to see if it wants to eat me, and you go on with your research? Is there like a feeling there when it looks at you, when you look back at it? It's early on, I'll be honest, it was a little unnerving. Yeah. It's like, what is that animal thinking and how is it perceiving me?
But as I've experienced it now hundreds of times, I don't feel threatened. I almost
Mm,
feel, and it's going to sound strange, but like Sai, I feel kind of a connection. Like that shark sees me, perceives me as something, is not threatening me, and is going about its business. And I just want it to live that way. It
yeah,
makes me want to respect that animal more. It's
yeah,
kind of like getting your child's attention for the first time, or your dog's attention for the first time. When you begin to really connect to an animal, and you get that feeling like, wow, this is, we have a relationship. It's odd. It sounds really strange because it's a big fish, and some of it think of it as a big dangerous fish. But those connections, I think, are important, even though they may be extremely simple and primitive.
hmm yeah. I'm just thinking that the fact that you're in this area for 20, 30 years now, sharks live for a very long time. You might have found a shark that you tagged when it was in its teens, and now it's, in its 40s, and it's had some babies and stuff like that. And I just wonder, if you see the same shark over and over again, if they're like, oh, hey, it's Greg. I don't know.
I
It may
want to
remember
say
to you.
that, you know,
Yeah.
I want to say, what's interesting? There was that shark that jumped up at me in the pulpit,
hmm
um, that we talked about, and we did see that shark again because we figured out who it was. And it didn't exhibit that behavior ever again, and we saw it a couple more times. But we've only been tagging the white sharks. Yes, they live a long time. We've only been tagging them though since 2009, and we
Oh,
have
well.
seen individuals going back to 2012. So we have seen individuals now almost every year, and sometimes every third year, fourth year. It depends on who that individual is, but over a span of a decade. And so that's really cool,
Mhm.
and it is, again, it sounds odd to the average person, but it is like seeing somewhat of an old friend, and I'm particularly, the scientist in me is still there. Don't get me
Mhm.
wrong. I'm not going to jump in the water and embrace these animals. I want to learn from them. But at the same time, I want to know what's happened to them since then.
Mhm.
Do you have any new scars? Have you grown? What is your growth rate? How have you changed as a shark? So I really love to learn from those old friends, and it's not like they sit down with me and have a beer and tell me everything they've done over the last decade. I've got to kind of, use my methods to interrogate them, so to speak. So the GoPro goes in the water, right?
Mhm.
And the tagging data will tell us a lot, right? So we can look at what that shark did. If you see a shark one summer, right, you tag it, and the tag tells you that shark went, all the way to the Gulf of Mexico, right, for the winter. And then it comes back, 2 years later or the next year even, and you see it again. That's kind of a really cool thing, right?
Mhm.
Um, because you're seeing a fish that went so far away and came right back to where you had met it. And you can learn a lot from that individual. And then when you've tagged 300 of them, you can learn a lot from all those individuals. And I'll tell you, Lowell, the thing that's frustrating but really cool about what we've learned about white sharks, and you see this in the book, I think it comes out really well, is how different these individual fish are.
Mhm.
Remember, sharks are fish. So anyone who goes like fishing for cod or striped bass, they know that those animals tend to hang out in schools, and they're kind of like carbon copies of each other, and they all seemingly do the same thing. But when you talk about white sharks, and what we've learned about them, you may be looking at a shark that's incredibly different from the one that you're going to see an hour later. Not in terms of how it looks, but it might look different, but also in terms of how it behaves. So, we don't like to use the term personalities in science because it's really hard to quantify what that means for an animal, particularly a lower vertebrate like a shark or a fish. But they do have different behavioral traits that I think are interesting. You might have one shark that prefers to come to Cape Cod and hang out in one specific area during the month of August, and then another one that comes and hangs out in a different area that month, or one that comes a month later and hangs out in the same area. So there's a lot of differences between these individuals that can frustrate you as a scientist because you're trying to find patterns, right? Because patterns lead to forecasting and predictability, and that's what science wants. But at the same time, it's really cool.
Yeah, it sounds fun. I would struggle not like finding a few that I like in particular and just kind of keep an eye out for them. Like maybe give them like special tags or something that could be more easily detected as they were like coming north or something. But that's probably anthropomorphization of an animal, which is what you're talking about, like the danger of being a scientist, but also feeling something too. I think sometimes people see scientists as like these lab coat people. And that's what's really cool about the show is like you get a long form conversation with sometimes scientists, and there's a lot of passion there. I think like science is just a framework to understand the world. And I think emotions and feelings are definitely part of the world as well.
Yeah, I agree.
So I like hearing it. Yeah.
No, Lowell, I agree 100%. There's two sides of my brain, and they're always fighting with each other. There's that emotional, spiritual fear, sometimes anxiety-ridden side versus the pure logic. And the time they clash most is generally when I'm about to jump in the water and swim with a white shark, which, we talk about in the book. That can be, that could be the great battle between the logical side and the emotional side. One says, "What are you doing? You're a land animal, Greg. Stay on the boat. Enjoy the shark from here." And the other one is, "No, man, I want to get in the water and see that thing."
I know deer, they can't see bright colors, so then hunters will wear like neon stuff, so then other people won't shoot them. Is it possible to have to detect what bands of light sharks can see in particular, and then like add like stripes or whatever to your suit so they know like this isn't a seal that just is this black thing moving through the water? It'd be less likely to bite you.
Yeah, great question. There's been a couple of researchers that have gone down the road. The general feeling now is that sharks in general, with very few exceptions, are colorblind. But they do really respond to contrast, right? So shades of gray, from dark to light. And so a couple of folks have proposed building wetsuits that are less likely to attract the attention of a white shark. And the problem is it's hard to do empirical tests on those. First of all, you need a whole bunch of volunteers who are not really willing to volunteer. So that's hard to do. Or you have to present an experimental protocol to draw the attention of the shark. And in order to do that, you typically have to stimulate the shark's appetite with something in the water like chum, ground up fish, and you've already biased your results. So it's hard to test the efficacy of some of these wetsuits that are designed to deter sharks, or at least such that sharks ignore them. But it's a road worthy of investigation.
Yeah. I was wondering, in reading your book and researching more on this topic before we spoke, the preventative measures that could be used. And in the north, I had some polar bear experts on a couple of years ago, and we talked about bloody what are they called? Penguin popsicles. Like a polar bear will eat them like a popsicle, and so it looks really messed up, as you can imagine. But anyways, they have like this like radar system type thing that detects like the size of an animal as it's coming. It's like, okay, that's a polar bear. Let people know. Lock down the hatches. Like, don't let them eat the children. And so I wonder, could there be a similar LiDAR type system detecting sharks off the coast and letting people know? Because LiDAR can get down to like, I think somewhere around 500 feet or 500 meters. I think it's probably 500 feet. And if they're typically within 20 feet of water, easy detectable, and then you know where they are, and then let people know like, hey, they're within like a quarter mile of a human. Maybe come out of the water until they get away, and then you put some in the water and make them scared or whatever, since they're so sensory sensitive. Like you put some like anti-shark smell in the water, make them go away. I don't know. But what do you think about that type of defense mechanism?
Well, I love your reference to polar bears. One of the chapters in the book talks about my work on Greenland sharks up in the Arctic Circle as part of my career, and my experience diving under 6 feet of ice, dealing with sharks, seals, and polar bears. But it's a little bit more difficult when it comes to working with animals in the water. LiDAR is great. It could give you a signature of a moving object in the water. Of course, you'd have to have a LiDAR, station of some sort, aerial station set up. That hasn't been tested in any way because of the expense associated with suspending such a system. We've used fixed drones as well as regular drones as early warning systems to detect sharks. And there's also over the last decade been the development of underwater sonar systems that will detect a large object moving through the water. Again, they're very expensive. The hard part and the frustrating part, I think, is not only the cost and the number of units you would need to do this, but there's a lot of other animals living in the area, specifically gray seals, which can give you a signature like a shark, whales, dolphins, other animals in the water, species of fish. So, in terms of differentiating between the species, you'd either have to have somebody who's manning the system who can understand the different signatures of each animal, or you would use artificial intelligence and machine learning to try to differentiate between animals, because certainly you don't want to keep clearing the beach every 3 minutes because a seal swims by. So that's being developed. So there are efforts being made to develop the artificial intelligence that would differentiate between a seal, a whale, a shark. It's not done yet, and it hasn't proven to be successful yet. But I think it's a promising road. Again, it comes at great expense, and you have to dedicate people to do these things in terms of operating these systems. But if shark interactions increase in a particular area to the extent where you've got to do something, this is certainly a road worth investigating.
Are there, I think I was reading in your last chapter a couple ideas that you had, but if you were to bet, we gave you all the money in the world and you had to build like the Shark Protector 9000 or something, what would be your ideal system for New England?
It would probably include multiple technologies because, based on everything published in the scientific literature, relative to the technologies that are currently out there, no single technology appears to be the silver bullet, right? You've got to use a combination of technologies. So if I had millions of dollars, I'd probably use a combination of drone technologies to detect sharks, but there are days where drones simply are ineffective. And certainly at night, drones are ineffective. And then again, there's costs associated with them, but let's assume costs are no big deal. I think the underwater sonar system is interesting, particularly since they're going down the road of trying to develop signatures for the animals they're identifying so that they can differentiate species. So I think a network of underwater sonar systems and drones would be, in terms of early warning and detection systems, the way to go. I think barrier nets, which have been tested in some places, certainly those that catch the sharks, we wouldn't want. There's no reason to kill these animals. But other barriers that these sharks can't penetrate would be very difficult to deploy, at least off the Cape Cod area, because it's such a high surf dynamic environment. And any given season, sometimes any given week, sand is moving in such great volumes up and down the coastline that anything you put there that was fixed, that you placed, that you built as a barrier system would probably be swept away. It's just one of those highly dynamic areas that would lead to the destruction of any fixed barrier system. So I don't think I'd go down that road at all. And when it comes to other deterrents, so there's early warning systems and there's deterrents. Drones, underwater sonar, those are early warning systems. Deterrents, those are tricky. People have said electrical fields, will deter sharks, and that has been demonstrated. But I'm concerned about the amount of electricity you'd have to pump in the water in order to deter sharks over a broader scale. Let's say I wanted to protect an entire beach by emitting, a lot of electricity. Well, I'd be concerned about anyone going swimming there because they may get shocked by it. So, I'm not convinced that electrical fields are at the stage they need to be at for broader scale protection. even though there is some evidence that perhaps, a surfer with a device emitting a very powerful electrical field may work. But that hasn't been vigorously tested. So there's a bunch of options, and probably more coming as time goes on. But I'd have to use a combination.
Yeah, there's an electrical field in a river outside of Chicago that they use to keep carp. The idea is to keep carp from going to the Great Lakes, and it doesn't kill the animals, just like stuns them, and they like kind of just drift back down the waterway. And apparently it's quite effective, and you can have boats and stuff going through there. I don't think you're allowed to kayak in it. I think that there are concerns that you'll get stunned and die. Well, mainly from like drowning. Like it's not enough to kill; it's just enough to paralyze your central nervous system or whatever. But therefore, I imagine a shark would require some significant, especially if they're like 2,500 plus pounds or whatever. It'd probably be a lot. And if it's like in an ocean as well, like it's like it's like half a football field in width of a river, and then it's like maybe like a 200 meters or a meter long, and then it just zaps up. Like that's a pretty small area to worry about, where you're working about like square miles, like massive amount of electricity. I don't know if you could actually do it like feasibly, like get the electricity out there to build that field. I'm poking holes in it as well as like an idea that I think is pretty silly.
Yeah,
like you have like a zone.
Yeah, you're definitely referencing electroshocking. And it's a great sampling technique for freshwater fish. When I was at the University of Rhode Island, I spent a few days in a river, electroshocking fish, and it stuns them, so you can collect them, measure them, take a sample, and put them back, and they will survive. Stunning a shark would be very difficult to do in terms, like you said, the massive size of the electrical field you would need. What the premise behind some of these devices that surfers or swimmers or scuba divers might wear is that the electrical field generating by them is not so great to hurt you, even though I've been told by surfers that their legs will tingle when they're in the water, but will overwhelm the electro-sensory system of the shark to turn it around and make it go away. So think of it almost like shining a really bright light into our eyes, right? And when that happens to us, we generally close our eyes and turn away. So imagine overwhelming a shark's electrosensory receptors on its nose to the point where it says, that's uncomfortable, I don't like it, I'm going to move away. It's not pain, it's just discomfort of some sort. Like I said, it hasn't really been demonstrated empirically to work all of the time, but it has some promising uses.
Yeah, I wonder if it would also help just messing with the targeting system. If its eyes are closed, it's relying on that system, and you have some electrical field in there. What if that like shifts it to the point where like it just really can't nib you too much? If you maybe it gives you a little bit more chances.
That's a good point. Yeah, it's a good point. And one worth investigating.
Yeah. So for tools to research sharks, what if similar question, just like I'm always curious, like you always work within constraints with science, like what you can afford, what you have, what exists. But if I just love the idea of just releasing a scientist's imagination, creativity. What all tools would you love to have if you could have them? Are there ones on the horizon, or that are too expensive that you can't have right now, that let's just give you a check from Bill Gates, now you can have them? What would that be like affecting your research? I'm just curious, like complete blank check on this, what would you need to do the research that you'd love to do?
I think what comes out in the book is the evolution of science and technology over the course of my career. University of Rhode Island, the best we can do is put a conventional tag on a shark, which is a tiny little marker that if somebody catches the shark again, they can take the marker off, read it, and they can report where they caught that shark. So we get a couple data points. Over the course of my career, which is a really exciting time, the last 40 years, right? We've seen an incredible, advancement in technologies that we use now to study marine animals. So what I'm most fascinated with, so we evolved through, satellite linked technology, acoustic technology that use sounds, to now camera technology. So we're putting camera systems on sharks that if you told me we'd be doing that, 40 years ago, I'd think that you were crazy. So if you asked me this question then, I'd say, wow, I would love a sophisticated tag that had a built-in tiny camera system. And hell, now we've got that. So I'm only imagining now how far, we can go over the next 20 or 40 years, right? My wish list would be, longer battery life. I love the camera tag systems, I'd like to improve our attachment techniques, figure out a better way to attach camera tag systems so they're more fixed on the animal. Again, not having to handle the shark, because we don't want to handle sharks. We want to just leave them alone. We want to keep them in the water swimming. We don't want to stress them out. A stressed shark next to swimming beaches is not a good idea, in my opinion. So new attachment techniques, camera systems that are smaller, battery systems that last longer, and satellite linkages so that we don't have to go collect the tag after it comes off the shark. Imagine if I could track a shark. Right now, I'm tracking sharks with camera systems for up to about 3 days. That's as long as I can track them. So I'm getting a real tiny snapshot into what that shark is doing every second over the course of a couple of days. Imagine if I can get a snapshot that is bigger than that, what the shark does when it migrates, to Florida and comes back. Imagine being able to spy on the life of a shark over really long periods of time with high resolution data collection and not having to get the tag back, but letting the tag transmit through satellite systems that can pierce the air-water interface. In other words, a tag that can communicate with satellites through water. That doesn't exist right now. So, obviously I'm wishing for something, big and expensive and may not be able to even get it. But newer, bigger, better tools are what I'd go for.
Yeah. I wonder, I was reading about battery renewal technology where essentially it was like a bunch of, the way I imagine it to describe it is like, imagine a bunch of barrels near a shore, and the waves hitting the barrels caused stuff inside of it to like cycle around and cause like a charge to build up, and that was like a battery that would then go be used somewhere else with electricity. I wonder if in these tags you could make use of the fact that sharks are they're just going to keep going, keep moving, and use that kinetic energy to recharge the battery, and just keep it like an everlasting one, and then use a buoy or some system when they go by them to like grab the data as it's near, and then the buoy itself would upload it, so you could kind of have like a battleship type grid and know where everyone is and what they're doing for a longer period of time because they're recharging the battery themselves.
No, it's a great idea. I love it. And those kinds of batteries are being tested, and I don't know if they can get to the size yet that can be packaged to put on an animal. And that's key, because in essence, all the sensors and camera systems and batteries and the package itself has to be small enough to be carried by now granted, this is a big fish, but you also don't want to change the behavior of the fish or cause it any levels of distress, right? You don't want to stress the animal out. So, the early versions of some of the tags we're using now were so big that you knew you were probably not studying natural behavior. Time goes on, things shrink, and in this case, shrinkage is good, right? And we're able to put these things on animals. So it's all about, smaller technologies, and that's happening. We're going in that direction, absolutely. But the idea of an array of listening stations, we've got one out now throughout the waters of Massachusetts that tell us where the sharks spend their time. But those have to be deployed every year. The batteries have to be changed. It's a monumental task to put out over 100 receivers that will detect the sharks, and also will only log the data, so they won't tell us in real time. So that technology needs to advance, and it's going in the right direction, because they didn't exist when I was younger. But it's exploding. And I love it. I mean, I think the tools that are going to be available for the next Greg Skomal are going to be really cool, really cool.
And then I was wondering if there's like catnip for cats, what draws them in and I don't know, gets them high or something. Is there an anti-catnip for sharks that you could put in the water when they're near and it'd make them go away?
So far, not yet. People have tried sound For example, we know orcas will attack and kill white sharks. So people have played back orca sounds to white sharks to see if that deters them. That hasn't been statistically shown to work. It's not no empirical data to support that. We don't know anything about any scents that might smells, any kind of chemicals we could put in the water. And you got to be careful with chemicals, right? Because we want to protect our coastlines. And so nothing that's working along those lines yet. And as I said earlier, people have tried various kinds of barrier systems, some with big, heavy earth magnets on them, and thinking that when the shark swims close to the electrical field generated by the earth magnet, which is strong, it swims the other way. But that doesn't work all the time. And again, you're putting something in the water that's got to stay there, and that's hard to do. So it's it's a challenge. It's a challenge. And there have been places that, again, in keeping it in perspective, shark attack, and I talk about shark attacks on the East Coast of the United States in the book. We talk about the few that have occurred off Cape Cod, in addition to some historical accounts that have occurred along the eastern seaboard of the US. And I don't shy away from shark attack. I'm not a scientist that buries my head in the sand and says, these are, warm animals that we want to hug. These are animals that every now and then, very, 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 very rarely will bite a person. And I don't shy away from it. So we talk about shark attacks in the book, and we go through how these events precipitate and what happens during them. But, in terms of deterring shark attack, and there are places around the world that have been dealing with shark attacks for decades, they still have not found effective measures to stop them completely. And so it's a difficult situation, but people need to keep it in perspective. Just because you swim in any ocean in the world doesn't mean there's sharks there that want to bite you. Okay.
Mm-hmm. Yeah. And thinking about sharks as an element in an ecosystem, what purpose do they serve? Like, if they were, to be deleted, what would happen to the ecosystems? And then what do they do? I imagine at the very least they're keeping the seal populations down.
Yeah, I mean, and there you just highlighted, Lowell, the functional role, one of the functional ecosystem roles of white sharks, right? Mm-hmm. We think of sharks, we think of any part of a marine ecosystem as being a piece of the puzzle. And we've all done puzzles where there's one piece missing at the end, and you're really mad because you just spent, a week doing a 2,000 piece puzzle and there's one piece missing and it doesn't look right. So think of the ocean the same way. And sharks are a critical piece of the puzzle because they're top predators, and you need top predators to exert what we call top-down predatory forces so that certain species don't get out of whack. And I think you mentioning seals is a good one, because seals started coming back to New England and Canada over the course of the last, 50 years. It's taken 50 plus years to bring seal populations back to what they once were. And that's because we decimated them. All right, but there are a lot of groups out there, and particularly commercial recreational fishermen, where the seal is not always a good thing to have around. They're competing with seals. Seals take fish off their lines, out of their traps. They mess with their gear. They're an all-around nuisance. So there's a lot of complaints about in their mind, the overwhelming seal population. And we talk about this in the book. Now, in my mind, the solution to a seal issue is to bring in the sharks. And naturally, that's what's happened. White sharks are drawn anywhere in the world to seal colonies if their distribution overlaps. And that's what's happening in Cape Cod. It's happened, in California, it happens in South Africa, in Australia, it happens in Mexico. All right. There are places around the world white sharks routinely go to feed on seals. And now it's happening in Cape Cod. So if we let the sharks do their job, which is to reduce the seal herd, I think some of those complaints are going to go away and we're going to get back to a naturally balanced ecosystem. So I think of this as a conservation success story. And that's really what the book is about. It's how we've taken steps relative to the decimation of seal populations and to some extent shark populations. And it's paying off, it's working, it's the goals we're trying to achieve, to maintain a healthy ecosystem. And sharks are a big part of that.
I think great white sharks have been around. I think I was reading somewhere that it's longer than trees. I think like sharks are older than trees. Like they're really, 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 really old. And I always wonder like what allows one species to exist for a long period of time and not another one. Like alligators are another example of this. And what is your hypothesis for why a shark has just been able to great white shark has been allowed it to persist for so long, when other similar species like the megalodon or whatever, which are great movies nowadays, it's very scientifically accurate, I'm sure, but went extinct.
The survival over the course of time. So it involves, evolution, right? And, species evolve. Now the white shark, it's important to put this in context. The white shark specifically, the species we know of, the great white shark now, Carcharodon carcharias, has not been around for the 400 plus million year history of sharks in general. So the early ancestors of sharks emerged at about 400 to 450 million years ago, which means, the general body plan, although it has changed over time, has proven to be successful. Their reproductive life history strategy proves to be successful. And that's what leads to persistence over time. You're going to get subtle changes. The white shark itself, the species we know of as the great white shark, has only been around 30 to 40 million years, but that's still a very long time.
Yeah.
And so for the animal to have survived and persisted when its cousin, it's the megalodon did not, is really quite fascinating. And the hypothesis range from the forage base of the megalodon going extinct. They relied quite heavily on the age of mammals, with the explosion of marine mammals to feed. With the loss of those species, it's thought that the megalodon could not persist. It's even thought that perhaps the megalodon was competing to some extent with the newer version of the megalodon. It's the emerging white shark, which has its own set of lineage of remarkable lookalikes as the shark evolved. But it's persistence through time has to do with having a body design and a strategy, a life history strategy that works. And that's what happens with sharks. I mean, the dinosaurs came and went during the time period that sharks have been around, and that tells me that what they're doing works.
Mm-hmm. Yeah, humans have only been around for like what, a quarter million years. Like we're not a long species. There's been which is weird that we only became dominant on the planet like 50,000, 40,000 years ago. And then for the majority of the time that humans existed, we were like medium apex predators. There was like other things that would eat us. But sharks, I guess, have been outside of killer whales and stuff pretty much on the top the whole time. Are we able to tell where they were in the order of things over the period of time? Just looking at the great whites over 30 million years.
Yeah, they've always been top predators. Megalodon was as well. What's kind of cool is the fossil record, which is getting better for sharks. Normally, it used to be based strictly on the presence, the structure of teeth, and that still is a major part of it. But also now, with preservation in certain types of conditions, we're seeing more than just teeth. We're finding actual structural components of the skeleton that tell us a lot, and we're even seeing prey species in the remains of sharks, which are interesting. So we could see that perhaps white megalodon, we're feeding on whales at the time. So the fossil record's getting better as science gets better at investigating it. But no doubt in my mind that this is a species that's always been at the top of the food web.
Is there an extinct species of shark that you would love to meet and not get eaten by, obviously?
Well, I think I'll travel down my childhood fantasies of meeting a megalodon. I think that would be really, really amazing to see, the megalodon shark, because of its sheer size. I mean, when I see 15, 16, 17, 18-foot white shark, I'm amazed by the size, the girth, the mass of that animal. So imagine what a 50-foot, 40-foot shark would look like. That to me would be incredibly impressive. But I think I'd want to see it from a distance.
Yeah. Are you as someone who is on the Discovery Channel, History Channel, has been on these different places and documentaries and whatnot, how do you like, I know you got your start with Jaws, you talk about this, but how do you like the Meg as like a series? Like there's like weird like Sharknado type shows, but specifically like the Meg, there's like two of them now, the Meg and the Meg 2, I think. They're very boring titles, but I think they're just picking up after Jaws. Like how do you feel about these movies when they talk about sharks?
I find shark movies entertaining. All right. I'm going to be the first to say that Jaws was a really, really entertaining movie for me. It was inspirational because of the character Hooper, which I talk a lot about in the book. I find myself in the same place Hooper was, the fictitious character was in the book. In the book Jaws, as well as I talk about it in my book and what I'm dealing with in terms of the politics of restoring a white shark population to an area where people like to swim. But the Meg movies, I find them entertaining. I really do. I find Sharknado movies really entertaining. I think it's fun to watch these things. You can't take it too seriously. Some of these scientists out there, they get all pissed off at, Sharknado, the Meg. They get pissed off at Shark Week. Oh, you're sensationalizing it. You're not doing real science. They get all mad. You know what? These venues, this is the world we live in now. Okay. You're engaging the public. They're going to watch these things. And if a kid walks away from, Sharknado with a smile on his face and perhaps a new respect for sharks or an interest in sharks, that's a positive. I feel the same way about Shark Fest, Shark Week. They're not all pure documentarian science. They're fun shows. They have to entertain at the same time. In my opinion, they need to impart a little bit of science. And if a kid watches a show I'm in that's a little bit goofy, where we do this so-called shark experiment and may or may not work, but that kid says that guy's got a cool job, then I've achieved my goal. That's fine with me. I don't need kids to all be bookworms and see only documentaries that are, really boring to watch. I loved them, but not everybody wants to watch those things, and I firmly believe those scientists who don't engage are part of the problem and not part of the solution.
It feels like they're it's more like they weren't included, so then they're going to act like they don't like it. I bet if they were invited to be on Shark Week and on these things to be panelists or whatever, like, I don't know, I don't have a problem with this much anymore. It's like they're probably just taking attention. Yeah.
I've seen evidence of that. I'm not going to name them, but yeah, you may find a name or two in my book. But yeah, there are scientists who, hated Shark Week and then were asked to be on Shark Week, suddenly loved it, but we're not asked to come back and hated it again. And so I think we know what that means. Jealousy is a very powerful emotion.
Yeah, I'm always surprised by how often people are jealous of each other versus just working on themselves. I guess it's easier to look at someone else and be like, oh, they have something, I want that, versus thinking like, what are all the steps that they put in to achieve that? Am I willing to do the same? Is that even what I want to achieve for myself? They just like see the status of things. And then they're like, oh, I want that, even though they haven't done any of the work. It's like
there are I think it's scientific field in general can have big egos, and I think it might be disproportionately more people in the field of shark science. Unfortunately, there are many scientists I know are great scientists. I know if you work on sharks consistently and you publish your findings, I know who you are. We know each other. And, some are wonderful people, and it's like any field, you get others, it's just the way it is. I hope that people, by reading my book, get a sense of who I am as a scientist and what I'm trying to achieve, while I'm having a great adventure.
Yeah, there's a story with chimps where there's like one that's really aggressive and there's some that are more like communal and work together, and the aggressive ones usually get pulled down at a certain point. Like that's what happens if you're just really aggressive. Like there's usually like a younger, more aggressive one that'll take you out, but the ones that are communal usually live longer and have happier lives. And so I'm just wondering, as you're like the great white of the shark experts, like what has allowed you to stay where you are at the top and to keep being on these shows and helping educate so many different people versus not be relegated to a different time in history. Like, it seems like you're always on the pinnacle. Whenever I'm doing my research over a period of my life, I've seen you a number of times. Maybe you have a different perspective on your life, but it does feel like you stay in the top 10% of shark experts, like the top 1% to 10%. That doesn't just happen. Like, there are people who want to tear you down. And so I always wonder, like, how do you just do what you love while also mitigating the fact that there's people there who are trying to get in the way of it?
Well, I'll tell you, Lowell. I appreciate those comments, and I try to stay focused. And one of the things I've done, although I'm changing this because the book is coming out and I need to reach more people. But I've avoided a lot of the social media bull, crap that happens. Social media draws you into these petty fights, and it's a great way for people to express themselves, and that's fine. But I don't want to be part of the negativity that can be, social media. Now I do have platforms, and I'm starting to work them a little bit more, because I want to engage people because of the book and for other reasons. I generally rely on the social media pages of, for example, the Atlantic White Shark Conservancy, which is a nonprofit I work very closely with. They do a great job of highlighting our research. But I stay focused, and I try not to take myself too seriously. All too often, scientists do that. They get in the weeds. I think they start to think that what they're doing is going to save the world, and maybe it will in 100 years. But I'm working one day at a time, and I'm doing baby steps, and I'm maintaining a positive, optimistic attitude, which I would encourage anyone to do in any field. Whether I don't care if you want to be, an engineer, whatever you want to be. A positive attitude goes a long way, and being willing to engage and listen to people and accept the ideas of others. You may not agree, but that's okay. It's okay to disagree. I publish papers sometimes that I don't necessarily believe is the perfect science, but it's the best available science. And if someone feels the need to tear that down, that makes them feel better. I don't care. You produce something better, but they typically don't. They tear you down to make themselves feel better. And I don't like that attitude. I don't like that approach. I like to be open-minded, and I like to give everybody a shot. And I surround myself with really talented people. And I've been lucky, I accept the fact that I've been very lucky, and there's nothing wrong with that.
Yeah. Well, I hope the luck continues. It sounds like if I were to consolidate this to advice for people who are looking to be in the sciences or look to focus on something that they could be great at, like you were great at when it comes to sharks, doing something very meaningful. It sounds like a level of humbleness, some focus, try and not be distracted. I think those are huge things, especially in today's, with the social media and everything going on, where it's really hard to ignore the negative, and people are constantly poking you. And I know a lot of my friends, when it gets into politics, they will spend the whole day like, oh, this person's doing this thing. It's like, okay, I understand it really concerns you, but like you're kind of wasted. Like the person's like owning your day for free. Like, are you gonna do I understand like you need a vent, but like, do you want to do something about it? It's like, no, I just wanted to talk about it. It's like, it's been like 8 hours. Like I've heard your points. I've heard your points. Like, what are you doing today to what you want to do? It's like, oh, well, I don't have any energy to work on the thing I had to work on today. It's like, well, you just wasted your day. Like the thing that you care about. And a year from now, I ask myself all the time, a year from now, when I look back at the thing that's bothering me, will I care about it? No. How about me not doing the thing that I do care about? Will that bother me? Yes. Then I'm going to do that instead. So it does seem like the focus, and then being mindful of the people around you. People always say like you're the average of 5 people around you. So I don't know if that's true or not, but if you're surrounded by people that are pulling you down or overly negative, and that's not to say like criticism is very valuable. So people who can look at you and say, hey, this is something you're doing that could be improved upon. That's really good. But people who are just like always pull down does, maybe, regulate them a little bit, but that seems like kind of a good encapsulation. Is there any other piece of advice or maybe particularly bad advice you've gotten that you would suggest people not follow as they're trying to like navigate their life to find what they want to be good at?
Well, I think you pinned it down. Lowell, you did a great job with that summary, and I believe in all those things, and I believe in a positive attitude, and I believe in constructive conversation, even constructive criticism. It's the destructive stuff you've got to avoid, and don't waste your energy. One of the things I've learned when I was really, young in my 20s, I had a lot of energy and I'd spread it out everywhere, trying to achieve something, and I did well. But I think I sometimes deluded myself. As I've gotten older, my energy levels are going down. I'm decades later, and now I know how to. With age comes wisdom in some cases. So now I parse my energy effectively because I run out of it by the end of the day. Sometimes before that. But the other message that I have for people is, no matter what you want to do, whether you want to be a shark biologist or an engineer or an astronaut or a greenskeeper or whatever you want to be, a great chef, whatever, focus on it and don't be afraid, think outside the box, put yourself out there. That was a big part of my life. I was introverted as a child, and as many people observe now, I'm not anymore, even though I like my private time. Get into your zone of that's not necessarily comfortable. It's tough. It's tough to do, but there's a lot of competition for a lot of different jobs, and if you have a dream for a certain thing, chase it. It's worth it. It's paid off for me. Maintain a positive attitude. You're going to have setbacks, and they're going to hurt. Don't let them throw you in the gutter. Stay with it. Persevere, stay focused, and do your best, and you'll get there. So that that's what I try to tell people. Volunteer. I volunteered. I think by volunteering, I for literally a couple of months, I would, if I didn't, I wouldn't be where I am today. So if there's something you want to be, go for it and do it. Do what you got to do.
That the last bit, just on volunteering, I've heard a number of people who are experts in their field, whatever that may be, that talk about how there's usually a nonprofit, there's an element of their work which is just volunteering, and they get a lot from that. So it sounds like one thing that is really critical to do is try to set yourself up financially as much as you can to have the space, to have the energy to apply to that, so that then you can start doing the things that you really care about. Not everyone can be born in the position to be doing these things, but I feel like if you can just 1% try and look for that opportunity to open it up and open up, like maybe over the course of a year, and I maybe not everybody, I don't know everyone's situation, but it does sound like, build a foundation so you can slowly open up the opportunity for you to be doing that type of work. Because most experts that I've talked to, there is an element of nonprofit or volunteering that they do, either in a short-term basis or routinely that they do, and they'll even say, I do this nonprofit, but this gives me so much more back, like referrals for business or whatever, and I would just do it for free regardless. It's just something generally they want to do, because it encapsulates their work very well, and they get to do the thing that they don't normally get to do, but from that, everything else comes from it. So to the extent you can, I want to be sensitive to anyone out there who is in a spot where they can't, make the little percentage changes so you can do something. Even if it's maybe you spend an hour a week writing emails to help out a nonprofit. You'd be surprised how little you need to do to have the biggest impact on other people. And so hopefully the advice that we're talking about, and if you do any of this stuff, put it in the comments or something, because I always like to hear what comes from the show. But for books, I'm always looking for recommendations of books. Your book will be in the show notes, of course, but what other books do you recommend people check out?
Well, I do a lot of scientific writing, and most of the stuff that I write ends up in peer-reviewed research papers that nobody reads, right? But what I've done in Chasing Shadows, which is more of a personal story, obviously, is I try to give the message of what how white sharks live and my own personal experience. I've done another book called The Shark Handbook, which condenses a lot of the technical aspects of shark science into something the average person can understand and enjoy, with lots and lots of photos. So The Shark Handbook obviously is a book I want to plug. I've got another book coming out in August called The Great White Shark Handbook, which is specific to white sharks, and again, lots of photos and condensing the information into really fun factoids and how we go about studying sharks. But there's lots of great shark books out there, and very adventurous shark books, and I enjoy reading them. Even though I know most of that stuff, I always learn a little bit of something. You know, there are great scientists that I think have done a good job condensing that information, and people want to see pictures of this stuff. You know, I've got a picture of a white shark's body cut in half, for example. You know, people say, "Oh, why are you showing that?" Well, there's a really unique aspect of white sharks that I think people need to see. You know, and I think people are drawn to those kinds of that kind of graphic information. So, yeah, we'll see how it goes, but yeah, one step I would do is, and I'm referencing just sharks, but yeah, I'm very much interested in any and most of the ocean books out there, and ocean adventures in particular.
Mm-hmm. Is there anything non-ocean that you're into, like knitting?
I will read thrillers, and
Mm.
because I find them entertaining, just to get off the grid a little bit with science,
Yeah.
because I think it's important to shut my scientific side down and just relax and read a good, murder mystery or something like that.
Yeah. And then last question, you mentioned a minute ago that sometimes before the end of the day, like your energy levels go down. And so I was just like questioning, then maybe a suggestion. When the shark tried eating you, when you were on the plank, did you have energy for the rest of the day?
Yeah, I had. So I didn't think much of it because it lasted less than a second, right?
Yeah.
But then I started seeing the video, and then I saw the video on TV, and I saw the video on all the different social vectors, and so it was like, oh my God, that thing got close. So I had lots of energy the rest of that day, and a bit of a smile on my face. And I didn't sleep all that well that night, though.
Yeah. Okay. Well, then maybe this idea isn't the best. Then instead of taking coffee, maybe you just go out and try to see if a shark will try and get at you again.
I think I'll avoid that, Lowell. I'm going to avoid that.
Yeah, probably. It's not a serious idea. Please, no one listening and do that. I'm not liable for anything that happens to you. But Greg, thanks so much for coming out today. Show notes to everybody for checking out the book, and let us know what you think. But Greg, thanks for coming on the show today.
My pleasure. Thanks, Lowell, for having me. It's great to be here.